UITM students have been struggling with monkey attacks in dormitories, causing messes due to trash being scattered by the monkeys. To overcome this problem, our group introduced the EcoSmart automatic trash can, an IoT-powered waste management system designed to enhance hygiene and prevent animal interference. By integrating gesture and object recognition, AI monitoring, and IoT communication, EcoSmart transforms a simple trash can into an intelligent system, promoting cleanliness and environmental awareness in student dormitories. Our main objective for this project is to develop a system that detects specific hand gesture. We implement an ESP32 camera to the trash can to detect specific hand gesture that triggers the lid to open, ensuring a touch-free and hygienic user experience. The ESP32 camera detects whenever a monkey is present and activates a water pump to deter them, preventing the trash from being scattered and ensure the dormitory's area cleanliness. An ultrasonic sensor is implemented to monitor the trash can's capacity and alert the user whenever it is full to prevent overflow and encourage timely waste disposal. Plus, when the sensor detects the trash can is full, it sends real-time notification to the user via Telegram app, informing the user of the trash can status. Lastly, to foster cleanliness and environmental responsibility by decreased manual contact, timely waste management, prevent monkey interference, and preventing waste scattering. For problem statement, this issue brings damage to the trash bin. Monkeys can damage or open the trash bin by tearing them apart or knocking them over, leading to waste spillage and the destruction of the bins itself. This results in more frequent maintenance and replacement costs. Not just that, it is also risking human-wildlife interaction. Easy access to trash can result in monkeys becoming accustomed to human presence and food, increasing the risk of conflicts and potential harm to humans. Lastly, it is also raising hygiene concern. Monkey rummaging through trash often leave behind unsanitary messes, which can attract pests, lead to foul odors, and pose hygiene concerns to the environment. For digital collaboration, we have visited Arduino official website to look for servos and ultrasonic scanner wiring tutorial. We use YouTube as a resource for ESP32 camera tutorial on how to set and code it. And lastly, we use Telegram platform. It is used for the system to notify the user when the trash bin is full. In this case, we're using Buffer acting for the notifier and intermediary between users and system.
My name is Faye Aurelie Alvin, and I will presenting the features of our project. The first one, automatic lid opening. We implemented a servo motor inside of the trash can lid triggered by specific hand gesture, which we use ESP32 cam to detect the hand gesture and open the trash lid. The second one is water pump. If a monkey is detected, the water pump will trigger and shoot out water to deter the monkey from rummaging the trash can. For the third one is fullness detection. An ultrasonic sensor is used for detecting distance to measure waste level and notify user if it's full via Telegram app. As you can see here, the user is notified when the trash can is full. For the fourth features of our project is connectivity, Wi-Fi integration for ESP32, using Wi-Fi connectivity to connect to a mobile app platform, which in our case we use Telegram as a platform to inform the user when the trash can is full. Fifth one is machine learning, gesture and monkey detection for ESP32 cam. We use an ESP32 cam module with TensorFlow Lite to identify hand gesture and monkey presence.
Here is the Gantt chart for our project management across 7 weeks. Hello, my name is Sean Daniel Sylvester. I will now be explaining the coding segment of the presentation. I will explain it slide by slide. Okay, so firstly, here is our coding for our Arduino in the Arduino IDE app. Um, Firstly, we entered the Wi-Fi credentials so that our Arduino is able to connect to the internet. Here, I entered the name and password of my personal hotspot, and then after that, we entered the credentials for our Telegram bot, which is responsible for sending the user notifications whether or not the trash can is full or not. Then afterwards, we defined every pin connected to the Arduino, such as the servo pin, where the servo is connected to pin number 18, the relay is connected to pin number 26, and so on and so forth, as well as the full threshold, where if the distance in centimeter is less than 3, when the sensor detects that, it will send a notification to Telegram. Now here in the next slide, once we connect the Arduino to the PC using a data cable, it will print out the words connecting to Wi-Fi on the serial monitor. And once it does connect to the Wi-Fi, it'll print out connected to Wi-Fi and generate its own unique IP address. After that, it will start a web server, which I will explain later, and initialize the servo, ultrasonic sensor, and relay pins on the Arduino. Next up, the Arduino loops the read distance function, where while there is no object within 3 centimeters in front of the sensor, it will print on the serial monitor no valid signal from ultrasonic sensor. However, once it does detect something, let's say trash, in front of the sensor that is less than 3 centimeters, the Telegram message alert trash can is full will be sent to the user or owner's phone. Now going back to the web server I mentioned earlier, basically it is a medium where it lets the object detection program send the data through the server and has the Arduino collect that data from the server. If the object detection program detects a gesture, like a human gesture, the Arduino receives that data as a gesture, and it will open the lid for 10 seconds before closing it. However, if it detects a monkey, the lid does not move and it will activate the relay, which allows a current to flow into the connected water pump, which then sprays at the monkey. Here's the send telegram message function, where it basically just sends a message notifying the user of whether the trash can is full through Telegram. If the message was sent successfully, it will say Telegram notification sent successfully on the serial monitor. If not, then it will state that there is an error sending the Telegram message. Now here is the function read distance, where it reads the pulse duration on the echo pin with a timeout of 30 milliseconds. If no echo is detected after 30 milliseconds, it will return an invalid distance, that is -1. It also calculates the distance in centimeter using the formula duration times 0.034 over 2. Then it returns the distance back. Now here is the Python coding for our object detection program utilized by the ESP32 camera. Firstly, it initializes the URL of the ESP32 camera so that it can get a clear and smooth video feed from the camera itself. Then after that, it initializes the URL of the web server generated by the Arduino so that it can send data to the Arduino with ease. Now, when the camera is placed facing an object, the object detection system will use a dataset library as well as a txt file containing a list of names for living and non-living subjects. The object detection program will compare the object in front of it to its library of data. So basically, let's say you put a mug in front of the camera. The object detection program will look through its library and then it will say that the object in front of it is a mug. If there is nothing in front of it that it recognizes, either it will not say anything or it will recognize it as something else, as maybe a kettle. After that, the object detection program, once it detects something is in front of it, something it recognizes, it will draw or generate a box around it with a label on it saying object and how confident it is that they think it's that object. So as I mentioned earlier, the mug, it will generate a box around the mug itself and it will say mug and confidence around maybe 90% sure that it is a mug. After that, it'll send the data to the web server for the Arduino to process.
There are three inputs for our project, which is gesture detection, we set it as A, monkey detection as B, and waste level detection as C. The output are as follows, which is lead, water pump, and telegram notification. And these are the truth table. For the last two rows, it is impossible for a person and a monkey to be detected, so we set it as X for the monkey input and the water pump output. And the last one, it is also impossible to have three inputs at the same time, so we set it as X for both input and output. Next is the sum of product for expression lead, water pump, and telegram notification along with their simplified Boolean expression. And lastly is the product of sum expression for lead, water pump, and notification along with their simplified version of the Boolean expression.
The following are the components purchased and used for the project, including but not limited to an ESP32 dev kit with its baseboard, ultrasonic sensor module, ESP32 camera, servo motor, relay module, jumper wires, USB data cable, a desktop dustbin from Mr. DIY, and a water pump with its hose.
I'm Rina, Ting, and I'll be presenting our result and discussion. The first picture shows the overall view of the trash bin and its components. Next are the pictures of the components inside the trash bin, the lid being opened once the ESP32 cam detects a hand gesture, and the relay to the water pump being triggered when the ESP32 cam detects a monkey. This is the output for when the trash can is full. The system will notify the user through a telegram of the waste level based on the distance. After thorough testing and debugging, we managed to ensure that the automated trash bin is working as expected and will process the expected output, such as the lid will open when the ESP32 cam detects a hand gesture, the water pump is triggered when a monkey is present, and a telegram notification are sent to the user to inform that the trash bin is full.
In conclusion, we have successfully designed an EcoSmart automatic trash bin, combining hygienic and timely waste management as well as addressing the issue of animal interference. This concludes the fact that by integrating IoT-based components such as ESP32, servo, ultrasonic sensor, and ESP32 cam model, it is possible to design an automated trash bin that prevents wild animals from rummaging the waste.
Next, I will be discussing possible future improvements for our smart trash can system. First is to improve object detection accuracy. Right now, our AI model can detect objects, but it's not always accurate. To improve this, we plan to train the ESP32 cam with more images, especially for hand gestures and monkey detection. This will help reduce false triggers and make the system more reliable. Next, we also want to improve the water spray deterrent. By adjusting the nozzle and water pump pressure, we can make sure it's strong enough to be effective but still safe. We are also considering adding flashing lights and alarms to further deter monkeys without harming them. Another improvement is to increase durability for outdoor use. Since the trash can will be placed outdoors, it needs to withstand rain, dust, and temperature changes. In the future, we plan to improve its weatherproofing to protect the electronic components. For example, by having a cover for the camera so it won't be damaged. For the last improvement, we're considering adding a weight sensor for better waste level detection. Right now, we use a distance sensor to estimate how full the trash can is, but this isn't always accurate. A weight sensor would provide more precise data, which helps to improve waste collection schedules and reducing trash overflow issues.